Yeah, thank you, Ken, for that introduction, and thanks to all of you today for tuning in and supporting our commercial crew program, and appreciate your interest in Boeing's crewed flight test. What we hope to do today is maybe clear up some information that's been out there and any misunderstandings about the flight and our status of Starliner and our path forward. First of all, there's no new issues to report today. We don't have any new problems we're working with Starliner or the International Space Station, so the vehicle at station is in good shape. I want to make it very clear that Butch and Sunny are not stranded in space. Our plan is to continue to return them on Starliner and return them home at the right time. We'll have a little bit more work to do to get there for the final return, but they're safe on space station. Their spacecraft is working well, and they're enjoying their time on the space station. I want to reiterate also that Starliner remains available in cases of an emergency or a contingency on the space station where the crew would have to return very quickly back to Earth. And as an example of that, on Wednesday night, unfortunately there was a satellite breakup in an orbit that was lower than the space station. And so the standard procedures at space station, if there's any risk to the space station as a result of that breakup, we have the respective crews go to their lifeboat vehicles, the Soyuz, Dragon, and Starliner. And in fact, we used Starliner for that safe haven capability. Butch and Sunny got in the spacecraft, powered the vehicle up, closed the hatch, and we're ready to execute, should they need to, an emergency undock and landing. So the vehicle remains safe, and Butch and Sunny used it, and it was great learning for us while we're docked at the space station to have this contingency come up. Obviously, we don't like these orbital debris situations, but it was great to exercise that. We've done that before with Dragon and our other vehicles. I also want to make it very clear it's a test flight, and we expected to learn about the vehicle, and that's really what we're about right now while the vehicle's docked at the International Space Station. We're about learning, and now we're embarking upon almost increment operations at the space station, and so we're not discouraged or deterring from learning while the vehicle's docked at the space station. We continue to work together with Boeing to improve our understanding of the two issues that we've been talking about, and I'll go into a little more detail on that before we step into the final return at the end of the mission. Remember, we don't get the service module back, so anything that we can learn on orbit is very important, not only to this mission, but future missions as well. I want to make it real clear that we're not in any rush to come home. As Ken said, the station is a nice, safe place to stop and take our time to work through the vehicle and make sure we're ready to come home. We talked about a 45-day limit pre-flight, limited by the crew module batteries on Starliner, and we're in the process of updating that limit. Essentially, the risk for the batteries is the same any given day on station, and so we've been looking at those batteries and their performance on orbit. They're getting recharged by the space station, and that risk hasn't really changed. So the risk for the next 45 days is essentially the same as the first 45 days, and so we'll go update that limit. I want to reiterate and remind folks that Starliner is really designed for a 210-day mission, and the systems are performing well. So with the extra time on orbit, we'll be watching the vehicle. We'll be watching the way the heaters work on the prop system. We'll be watching the way that the space station continues to power the vehicle, characterizing the thermal performance of the vehicle, and then obviously Bill Spetch will talk about all the activities that Butch and Sunny are supporting on the ISS. Now let's talk about the two areas that we've been focusing on. One is the helium leak. I just want to remind everyone we're not leaking any helium while we're docked to ISS. We have those manifolds closed, so we're not using any consumables in that area while we're docked. We did a leak check back on Saturday, June 15th, and the leak rates actually went down in all the manifolds, all the 5 that were leaking. So now what we're doing is we're taking our time to govern by the fall tree that we put together, to look through the system, to look at analyze data, and to close out blocks on the fault tree. I know Mark will talk more about that. We're going to continue to verify the helium margins and double-check those before we undock. We'll review the management of the system. In fact, a few days ago at the Starliner mission management team, we talked about the crew's capability to respond to a leak. We wanted to double-check the software, double-check the items in the software to make sure that that was correct for return. And then we're going to do more testing on the ground. We've done some testing already with this flange that we talked about pre-launch and the seal on those flanges. We've applied heat to those seals to simulate thruster firings. We've damaged some seals and done testing. And we're trying to make sure we understand exactly the root cause as best we can on the ground. We'll also do some testing at White Sands to understand exposure to hypergol vapors. We don't think that's happening, but we want to just double-check that item on the fault tree. And then finally on the ground, we're also disassembling several thruster flanges to see if there's any causes there related to improving our understanding of the leaks that we're seeing on orbit. So again, nothing has changed with the leak rates. We're in exactly the same posture we were. We have the margin we talked about before. We need about 7 hours of helium to get undock and get to the deorbit burn and the SM disposal, and we have 10 times that margin. On the thrusters, we're taking our time while docked to look at all the data from all the previous flights. On the Orbit Flight Test 1, we had some very aggressive thruster firings on that flight in the early phase of the flight where we had a lot of heat put into the thrusters, and we're working through that data. We want to have extra time as well. We did the dock hot fire a number of days ago, Saturday, June 15th, and we're analyzing all the data from that. It's difficult to get the precise measurement of thrust that we would like, that our thruster engineers would like because of the massive size of ISS, but the team's done a great job, and we know that the thrusters are performing somewhere between 80 and 100% of the thrust on each thruster. And they performed well during the rendezvous and docking. In fact, one thruster actually fired after we had hot fired it on the docking day another 575 times. We worked to look at the imagery that we took at ISS with the robotic arm, and we didn't see anything off nominal there. Any of that imagery looking into the throat of the thruster, looking for erosion or anything that would be an area of concern. Given all the data we've looked at so far, we want to embark upon a test campaign at the White Sands test facility to replicate a thruster firing that we've seen during flight. So we've picked a thruster. We'll go put that thruster, a new thruster, through the same profile that we saw on the uphill phase from on-orbit insertion all the way to docking. We'll recreate that profile. Then we'll put a pretty aggressive profile in the thruster for the downhill phase, and then we'll give engineers a chance to go look at that thruster and take a look at it and make sure that there's nothing that's unusual about the thruster. And so that's the one new thing that we're talking about today that we haven't talked about before is a set of thruster testing at White Sands that starts. The thruster is already being put into the chamber. We should get into the first, what we would call acceptance testing, which is a normal kind of test, as early as Tuesday the 2nd, and then probably a couple weeks of testing with that thruster to understand its performance. And this will be the real opportunity to examine a thruster just like we've had in space on the ground, the detailed inspection. Once that testing is done, then we'll look at the plan for landing. We don't have a targeted date today. We're not going to target a specific date until we get that testing completed, and we look at the fault tree, and then we understand the path forward. So essentially it's complete the testing, complete the fault tree, bring that analysis into this SMMT, and then have an agency-level review, and then we'll lay out the rest of the plan from undock to landing. I think we're on a good path. I want to thank the Boeing, the NASA teams all across the country working so hard on CFT. They've been working for many long hours. We're starting to, in the increment phase, give them time off, which is well-deserved. They continue to dive into all the details of the fault trees, close out the blocks, and again, we'll update you when we get the results of some of the testing, and then we'll lay out a path forward for landing. And I think with that, I'll turn it over to Bill.
Thanks, Emily, and thanks, everyone, for joining us. I'm going to try to do the same thing that Steve did and try to clarify a little bit. Every morning, I've got Google alerts set, and they send me Starliner stories. And so every morning I sit and I read them, and I'll tell you, from being a representative of Boeing and a representative of the Starliner program, it's pretty painful to read the things that are out there. We've gotten a really good test flight that's been accomplished so far, and it's being viewed rather negatively. This morning I did my normal routine, and I was thinking about what I was going to say in my opening remarks, and I stumbled across Ken Kramer's interview on Starliner. He really did a nice job, and it's because he kept it simple and he just stated the facts. So thanks for that, Ken, and I'm going to try to do the same thing as I walk through my opening remarks and clear some things up, explain why we're staying on ISS longer and why it's a win-win for everybody. First, I'm going to repeat the same thing that Steve said. We're not stuck on ISS. The crew is not in any danger, and there's no increased risk when we decide to bring Sonny and Butch back to Earth. Let's recap a little bit of where we are today. We had a really perfect launch and orbital insertion. We've met all our flight test objectives. We had these operational checkouts that were over and above the flight test objectives that we've also completed, and we've added more. In addition, we've learned a little bit more about what an extended duration mission is, and we would have not learned those things had we just stayed up for 8 days. So we're docked and we're safe. We have an approval to be a lifeboat in case of an emergency on ISS. That means we can return with the Starliner at any time, and that was proven this week, as others have mentioned before me, with the conjunction that was identified, and the crew used the Starliner as a safe haven, and if needed, could have returned to Earth. So now, why are we staying longer, and what are we doing? Well, we had two anomalies. Everybody knows about them: the thrusters being deselected during approach and docking, and we had the helium leaks. We understand these issues and for a safe return. What we don't understand these issues enough yet for is to fix them permanently. Again, I'll say that again. We don't understand these issues well enough to fix them permanently. And the only way that we can do that is take the time in this unique environment and go and get more data, run more tests. So the way we address issues like this is we build fault trees. Sometimes these fault trees have 80 to 100 boxes, and they're all possible causes of why we're seeing what we're seeing. Then we take that data that's available to us and we run tests, and we try to eliminate every single one of those boxes to narrow down to the most probable cause or maybe the root cause. And then once we get down to those few, we can apply fixes to them and eliminate the problem. And that's exactly what we're doing right now. While we have this unique space environment, ISS has welcomed us to stay longer, and the crew's happy to be up there. Let's take the time to learn. Engineering loves data, and this is a really good technical opportunity. Some of the testing that we've done so far, we ran the hot fire test while we were docked, and now we're going to try to replicate what we saw during the docking with a ground test that Steve mentioned earlier. We want to see if we can gain more knowledge and see if it will tell us more about the causes. We want to determine if we should do anything more in flight. Maybe we should try to do more hot fire testing while we're docked. Maybe we want to do something when we do undock with additional hot fires. So running this test will give us more information so that we can make those decisions. This ground test is simply attempting to recreate the space environment and the thruster firing profiles. And we want to look at the results and then determine whether or not we want to do more testing. We may or may not be able to replicate everything exactly as it happened, but we do believe we're going to learn some things from this test with respect to the individual thrusters and help us in our root cause investigation. And that all leads to improving the system for the future. So we have an end-to-end plan. We have a number of actions that have been defined that we're going to go complete. After it's all complete, we'll meet, we'll make sure we did everything we needed to do to understand the system, then we'll come home safely. We're not sure when that's going to be yet because these tests are unpredictable and how long they take and how successful they'll be. So we'll run more tests while we're docked, or we may run more tests while we're docked. We may figure this out and need to do some things after we undock. But when we do figure this out, we're going to return safely, and we'll set a date for that when we figured all this out. Again, we're not stuck on ISS, crew's safe, and we're going to return home when it's time safely. If this isn't clear, please ask us more questions. We want to really leave here today with a good understanding. One last thing, we've had 4 opportunities to talk to the crew. I had one personal phone call with Butch, once with an all-team downlink session where Sonny and Butch talked to our Boeing, ULA, and NASA team. We had one FaceTime with Sonny where she gave us a tour of the ISS. And lastly, last weekend, Butch and Sonny sent us a really nice email about what they've been experiencing up there and what they wanted us to know. And the takeaways from that was they know this is a test flight, and they knew that we would learn, and this is all good, and it's all not unexpected. They're in great spirits, and they're enjoying their stay on ISS, and the Starliner spacecraft has been, in their words, pristine and precise. Thanks, and back to you, Josh.